Students wanted machine, airway, and other allied topics. So I thought instead of just blindly telling them about it, I will prepare the topic on Osce basis with question answers, so that they can, it will be interactive. They can try to answer the questions, and then they are not able to answer, they can learn the answers also. Okay. So shall we start?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So hope my screen is visible for you. Here we go.
Yes, sir. Yes, sir.
Okay.
Yes, sir. Visible, sir.
Now, what is shown here? A very common scene in all the OTs that you see. Pipeline
Color-coded wall-mounted pipeline.
Wall outlet.
outlet, not inlet. This is the outlet for gases. So it is a color-coded. What type of outlet?
Wall-mounted.
Wall-mounted. But what is the name of the
Self-sealing.
type of
Self-sealing outlet.
this portion? What is it called? This metal portion which you see here projecting in all these.
Diameter index.
Diameter index, but what is the person's name who devised this particular thing? Hmm? Supposing there is now there is no hose attached to this. Will the gas be leaking? Will you get oxygen flowing all the time? Will you get nitrous oxide wasted? Will you get an air, a medical air getting wasted?
No, sir. We have
No.
check oil.
Now, is it called check valve or some other valve?
Self-sealing valve, sir.
Self-sealing valve, very good. It's called color-coded wall-mounted self-sealing high-pressure gas outlets. Okay, color-coded wall self-sealing high-pressure gas outlets, also known as Schrader valves. SCHRADER, Schrader valves. Okay, so that is the thing that has been noted. Why it is color-coded? What is the purpose of color coding?
To prevent misconnection of the
That for that you
hoses,
have
sir.
the names written here. For whom it has been color coded. OT boys, do you think all of them will be very much educated? Of course, nowadays there are courses to qualify yourself as a OT assistant or OT nurse or all these things. But earlier, it was all unlettered people. Ward boys and other people were used as OT assistants, and most of them were not educated. Okay, so they cannot read English, they cannot read the names. So it is mainly for the unlettered people. It was given color coding. Okay, and also even for lettered people or educated people to easily pick up the particular type of gas to which it has to be connected. Okay, what are the safety features in this? Somebody said diameter index safety
They're
system.
color coded and they have diameter index safety systems.
And also point I told you, name of the gas is also written here. Okay?
Yes.
So it is color coded to enable unlettered people to identify that. Name of the gas is written on the cover for those who can read. It is self-sealing to prevent gas leak and wastage when not in use. An arrow pointing the direction to turn to release the probe is also given here. Okay, you can see this arrow mark here. Release. It is written in everything. Okay. So that you don't unnecessarily meddle with it and try to unplug or remove the probe that is going to be inserted. So that release mark is also written on the cover of all these things. So 4 points you have to know: color coded, name of the gas written, self-sealing to prevent gas leak, and arrow mark pointing the direction to turn to release the probe. Also, probes inserted to deliver gases have diameter specificity to prevent wrong connection. Okay, so that is the thing. Now, what is shown here?
Color coded hose pipe.
Color coded high pressure hoses. They are called hose, not hose pipe, but they are called high pressure hoses. These are probes actually, and it is majority of them are showing the probes so that you can identify the different diameters here. You know, the probe tip goes in here, and then it will get locked only at the particular. So the white one will go only into oxygen. The blue one can be fitted only to nitrous oxide. You cannot insert the other one because the diameter here at the neck will be varying. So it will not fit into the improper outlet. So these are probes for different gas with their color coded high pressure hoses, namely oxygen, nitrous oxide, medical air, and vacuum. Which one is the vacuum here?
Yellow
Which
one.
color? Yellow, correct. Sometimes it can be black also. Vacuum can be demonstrated as black. Medical air can be slightly gray, okay, or yellow. What is the pressure at which the gases are delivered at this point and why?
It's 400 kilopascals.
400
PSIG or 400
50
kilopascals.
psi, kilopascal. Okay, right. 50 to 60 psi. And why is that? What is the reason that all of them are delivering at 50 to 60 psi?
To avoid damage to the flow meters vaporizers.
Avoid damage to the flow meter. Does it go directly to the flow meter? This 50 to 60 psi.
So
If it goes directly to flow meter will get damaged because
yes, sir.
flow meters are not designed to face 50 to 60 psi. They can face only 14 to 15 psi. There is a pressure regulator or reducer. The reason, so the pressure is 50 to 60 psi. This is because when oxygen or air is used to drive a ventilator, it needs 60 psi pressure. Okay. Nowadays, you know, some of the all the anesthesia workstations come with their own ventilators. Majority of them can have their generating power, the pneumatic power by their own mechanism. But sometimes earlier machines used to depend on the oxygen supply, which will be partly diverted to the ventilator to drive the bellows. So earlier models used to utilize this air or the oxygen for their functioning, and that can work only when there is a 60 psi pressure. So that was standardized at that particular thing. How is the secure connection of the hoses tested?
Tuck test.
Tuck test, sir.
You have to do tuck test. Very good. Tested by tuck test. Now, what is shown in these pictures?
Cylinder manifolds.
Cylinder manifold. Okay. So manifold with two banks of cylinders. Okay. So here you can see in the B picture, you are seeing one bank here and this is another bank. So this is a manifold room with two banks of cylinders. What is this?
Gas storage.
This is the correct method of storing the gases. So the gas cylinders, portable gas cylinders, should not be made to lie horizontally on the floor. They should be kept always vertical with the individual support, so that this is the correct method of storing the gases. What gases can be delivered from a manifold room? Is it only oxygen and nitrous oxide, or some other gases also can be delivered?
Carbon dioxide, medical air,
Medical air, very good. Then
um, nitrous oxide cylinders.
nitrous oxide, oxygen, commonly we get it. That is agreed. Carbon dioxide is right. Medical air is also right. Any other gas?
NOx, cyclopropene.
Entrodox is not delivered from manifold room. That much of usage is not there. But in Western countries, they use heliox also. Okay. So oxygen, nitrous oxide, medical air, carbon dioxide, heliox, nitrogen, and instrument air. That is the orthopedic surgeons when they want to use the drill, or neurosurgeons when they want to use the burr. For all these things, you need a instrument, non-medical air. It is called instrument air. All these things can be delivered from manifold room. What are the safety features in a manifold? The exam, they ask you every point what are the safety features. Because now we are starting from the storage and delivery of gases. That is the starting point for knowing about the anesthesia machines. So at every level, we must know what are all the safety features that have been incorporated for the safety of the patients.
A one-way valve so that the full
They have-
cylinder cannot empty into emptied cylinders.
Okay.
Cut-off valve with pressure indicators, sir. So
Indicator. Okay. Okay. So the header bars will be equipped with high pressure shut-off valves outside the cabinet to allow for emergency isolation of the header bars. So this is called the header bar. Okay. This portion where all the cylinders are connected with a strong pipe, this is called the header bar, and this is called the pressure shut-off valve area. So if you open that, there will be a lever which you can just, so the cutting of valve should be outside the cabinet or the pressure bars, and the header bar shall incorporate integral check valves for each station, and the manifold is equipped with pressure transducers. It sends information to the main circuit board for operation of the fail-safe relay, which transmits a remote signal to the master alarm or a buzzer. So whenever one bank gets empty, the pressure transducer will sense the fall in pressure and immediately send an alarm, even though automatically the other bank has to open and it will start supplying without any interruption. But to indicate that this bank has become empty, there will be an alarm so that the person managing or guarding the manifold room will know that these cylinders have become empty and he will start replacing them with the fresh ones. So that alarm or buzzer will sound once all the cylinders of one bank become empty. That is achieved by a pressure transducer which senses the fall in pressure, and automatically it will also open the other bank. These are all the safety systems. So this is a close-up view of the gas manifold. You can see the levers are inside. So all the pressure gauges show the various pressures. So this is a close-up view of what we are seeing here in the middle. Okay, that is called the gas manifold. So this is what is incorporated. This is a very important part of the manifold room. Now what is shown in these pictures?
Liquid oxygen tanks.
Liquid oxygen.
Liquid oxygen tank. Very good. So this is a method of liquid oxygen tank. What is shown in this picture?
Filling of the liquid oxygen.
There's a tanker which has come, which is filling the liquid oxygen. You can see the hose going there. So when the liquid oxygen is exhausted, it is getting refilled. Instead of the simple small portable cylinders, they will be replaced with the filled ones, just like you get a gas connection and gas cylinder being replaced at your home. But for liquid oxygen, this cannot be done because the tank is so huge that you cannot transport it every time to fill it up. So instead of that, just like the petrol bunk stations, the tanker will come and it will fill the liquid oxygen tank and replenish whatever stock has been utilized. So this is the filling of liquid oxygen. And what is a vacuum insulated evaporator?
So it is
VAE.
double walled, insulated to prevent the change in temperature of the liquid oxygen tanks.
Okay. What gases can be stored in them and for what purpose? This VAE used
Oxygen.
oxygen commonly, then
Present.
nitrogen. Okay. There are two parts in this question. What gases can be stored in them and for what purpose?
When the demand increases, we can use the oxygen from liquid oxygen
Okay.
tanks.
So it is a form of pressure vessel that allows bulk storage of cryogenic liquids, including oxygen, nitrogen, and argon for industrial processes and medical applications. Okay. So the three gases which are having a cryogenic property are oxygen, nitrogen, and argon. So of that we are using only oxygen for medical purposes. The other two are for industrial purposes. What are the technical considerations for hospitals to set up a PAE system?
Should be
It should be
isolated
away from the
building.
main building.
Very good. It should be away from the main building. Then can just looking at
Concrete
this picture, you
slabs.
can notice how it is erected, a strong platform, how the pressures are there. Okay.
Its slabs are there, sir.
Concrete platform, yes. Capable of storing liquid oxygen, which is cryogenic in nature at approximately minus 183 is the boiling point. And standard operating pressure of bulk tanks is 16 bars. However, some can also be as high as 35 bar. So liquid oxygen tanks are very heavy and require specifically designed reinforced concrete slabs to bear the loading. So you can see here the concrete slabs are there, and sources of ignition are prohibited within the storage location. So no fire should go near this, like smoking or other inflammable materials should not be brought near that. Is the picture clear for you?
Yes, sir.
Yes, sir.
So you are seeing A, B, C, three components in a single picture. What is A, what is B, and what is C?
A, they are doing a tuck test, sir.
Excellent, very
B,
good.
they are
Great.
trying to pull it out, sir.
Remove the pipeline.
B, we are removing
B is
pipeline.
removing pipeline, pulling out the pipeline.
Pulling. B is pulling out or C is pulling out?
B is pulling out,
B
sir.
is
They
pulling
are
out,
Trying to
sir.
removing,
connect.
It's pulled
removing
out.
in B, sir.
Out.
B is pulling out.
What type of connector is that B? Is it like A or is it different?
It is non-interchangeable screw threaded.
It is NIST from a ceiling pendant. Okay. Whereas the first one is a wall mounted, as is shown in the first picture, it is a wall mounted self-sealing or Schrader valve. It is also written in very faintly the Schrader valve and Schrader probe. All these things has been marked with arrows, and the person is doing the tuck test to find out the security of the connection. Whereas here it is, you can see the pendant here, that box-like thing, to which the gas oxygen outlet hose is being attached to the non-interchangeable screw type connection. And here you can see, this is what is this portion? This is the machine end. This is the older machine, not your newer workstation, but it is the older anesthesia machines. What is this blue thing called?
Yoke assembly.
Yoke assembly. Very
Hanger
good. Huh? It's called yoke assembly. Huh? And in this yoke assembly, again, there is a Schrader type valve. Okay, so this is the Schrader probe which is there, and hose is going from downwards. whereas here it is on the reverse side. The probe is going here and the Schrader valve is fixed to the wall. Whereas here the probe is fixed to the yoke assembly and the Schrader valve will be inserted here. This is an older type of connection. Okay. So A is wall outlet with Schrader valve and Schrader probe for oxygen nitrous oxide connected and tuck test being performed for the oxygen hose connection. B pendant type outlet with oxygen hose being connected to that. C is Schrader probe with pin index for the what gas we don't know because the hose color is not visible, and with a separate Schrader valve down here. So this valve can be introduced here and we can continue with the pipeline supply going to that. But some of the other machines we have other type, and you can, what is being seen here. This is a
Hanger yoke
closer
assembly.
view of another.
Hanger yoke assembly, sir.
Hanger yoke assembly.
Hanger yoke assembly.
Hanger yoke assembly. So how many are there? You must describe the entire thing.
Of oxygen, nitrous oxide, sir.
And
Nitrous
one empty.
oxide, one is empty.
Empty.
Okay, so 3 hanger yoke assemblies, and it is written here very faintly. If you can see closer look, air. So that air connection is not given, but nitrous oxide and oxygen are there. And here there are other connections also on the back. Okay, so this is the back side of a newer anesthesia workstation where spare cylinders can be attached here. Okay, so 3 hanger yokes are seen with oxygen nitrous oxide cylinders mounted on them, and the hanger yoke for air is empty. So here it is written air, so it is written empty. What are the parts of a hanger yoke assembly? Now that you are seeing the entire thing here in the open as well as in the used position, you must be able to say what are all the parts of this hanger yoke assembly.
So Bodox seal,
Bodox seal, okay.
Gland nut,
Cylinder
sir.
pin
valve,
index system,
One at a time.
Index system.
Bodox seal is a part of that, okay.
Gland nut.
Gland nut. Does it have a gland nut here? Gland nut is in the cylinder. See, this is the gland nut. This is the cylinder.
Okay,
This
sir.
is the cylinder valve portion. This is not part of. This is mounted here.
Yes, sir.
But these are all the components of hanger yoke assembly. You are seeing Bodox seal. Where is this Bodox seal seated? What is
Washer.
this?
Washer.
No, this
into
is
the
a washer
between the
like thing.
cylinder and the
But
yoke
what is
assembly.
it guarding? This washer, what is it guarding here? What is this hole for?
It prevents the leak
Inlet.
between the cylinder and the
Oxygen inlet.
yoke assemblies.
inlet.
But what is this? What? Where is the leak likely to occur? This is the entry port for the gas. This is hole.
That was the pin
This-
pin where we attach.
Pin is here at the bottom. I'll show you another close-up
This-
picture. These are the pins for pin index. You can see faintly the projecting pins here. Okay? So the pins of, and the cylinder valve will have the holes for the pins to go in. But this is the main entry port for the gases. Okay? And how these cylinders are held in position or mounted in position?
Screws, sir.
By
The
this-
retainable screws. The
It is retainer screw and the handle. Okay, this is called the T handle, and this is called the toggle lever. This is called the toggle lever, which is open now. Once you put the cylinder here, you rotate it. It will go and get seated here, and then you tighten this white thing. It will go and fit on the back side. We have pictures of that, how to show in later slides. So the body, which is the principal framework, this is the body of the yoke assembly, and this is the one which is supporting the entire weight of the cylinder. The retaining screw is the one which is going from here, which tightens the cylinder with the yoke, also known as the T handle. This is the white thing is called the T handle. The third is the nipple through which the gases go. This is the entry port or nipple through which the gas enters the machine. And there are 2 index pins which prevent attaching an incorrect cylinder below the nipple port through which the gases go. There is a Bodox seal, the washer which helps to form a seal between cylinder and yoke, and a filter to remove particulate matter. This is inside here. Okay, so these are all the. And seventh one is a check valve assembly which ensures a unidirectional flow of gases through the yoke. So there are totally 7 components of hanger yoke assembly: the body, the retaining screw, the nipple or the entry port, the pin index pins, and then the Bodox seal, and then the filter inside which is not visible, and the check valve again which is not visible, which will allow only the gas to go from here and not come out from the machine to the cylinder back. Okay, so all these parts you have to mention in the answer. What are the things that are shown here? This must be very familiar to all of you because you are using your workstation every day. You're seeing this every day morning when you go to the OT.
APL
Adjustable.
APL
Adjustable
valve is there.
Adjustable.
with the pressure gauge.
Pressure gauge.
The pressure gauge.
Pressure gauge.
Is it for airway pressure or cylinder pressure?
Airway
Airway
pressure.
pressure.
Airway pressure.
Airway pressure gauge. Then
And the toggle between the bag and the valve.
Lever of the
Yeah,
it's called the
machine
lever
ventilator.
switch from bag to ventilator. So APL valve knob, airway pressure gauge, lever to change from bag to ventilator. These are the 3 components which are shown here. What is the function of APL valve?
It helps providing positive,
Positive
pressure
pressure.
ventilation during bag
Resistance
ventilation,
Hmm.
manual ventilation.
Okay.
And also it helps in venting out when the pressure inside the machine is high.
Okay. Supposing patient is breathing spontaneously, does this valve have any role?
Can
Yes,
provide
it provides a peak.
No.
peeps.
CPAP or PEEP. Okay. PEEP during control, but CPAP during spontaneous ventilation. What is the maximum pressure that you can get by closing this valve?
60 centimeters of 60 to 70 centimeters of water.
It's written here.
70 centimeters
If
of
you
it.
observe carefully, you will be able to see. Are you able to see that number 70 there?
Yes,
Yes,
sir.
sir.
And this is minimum. Means it is close to 0. Okay. So this is the amount of pressure that can be. So the adjustable pressure limiting valve, anesthesia machine circuit, relates to the gases into the scavenging system and reduce the internal pressure control in the breathing circuit during controlled ventilation. Continuous positive airway pressure or positive end expiratory pressure is added to the circuit by partially closing the valve during spontaneous or assisted ventilation respectively. What is the working principle of the pressure gauge?
Board special. Good. Board. Cylinder pressure is measured by Bourdon's pressure gauge, which is a flexible tube which straightens when exposed to gas pressure, causing a gear mechanism to move the needle pointer. So this is the picture to show you how this is the way the gas pressure enters the pressure gauge, and once it goes, it straightens try to straighten this malleable tube, and this pointer will move showing the pressure inside. What are the safety features incorporated in the pressure gauge? This is a very common question in the Viva.
If the pressure is high, it will rupture in the posterior side to prevent
Okay.
damage.
Name and
Always
symbol
you
of
want to
the
start with the
gases.
complication, not with the regular safety features.
Name of the gases is written.
Name of the gas is written.
Color and the name.
Color coded, yes, very good. Then in some machines you will find there will be instruction, no oil, no dirt, so that to prevent explosion. And of course, as you said, the backside is made up of thin, and any increase in pressure and damage, it will rupture only on the backside without causing any damage to the anesthetist or the patient. And in modern machines, instead of a straight mounting, they have an angulated mounting for easy visibility. Okay. So here, if you see, this is going straight, but there will be a stem here, then the gas will be in an angulated position so that you can easily see it from any angle. So if there is a sudden increase in the pressure and the tube ruptures, then high pressure gases are vented from the back, preventing injury to the patient. Pressure gauge is color coded with the name of the gas written on the dial. And in modern workstations, pressure gauges for both pipeline and cylinder supply are provided. Whereas in the earlier machines, only the cylinder mounted pressure can be read from this. The pipeline pressure or central supply pressure will not be there. But in your modern workstations, you will find both the pipeline pressure supply pressure as well as the cylinder supply will be seen. All these things are added advantages or safety features. Now we come to the important point, what is shown here. You have been talking about gland net and other things.
Cylinder valve.
Stem of the cylinder is shown here, anterior and posterior side.
Valve assembly.
Valve assembly.
This is the whole thing is called the valve. Okay, the entire thing is called the valve assembly or valve of the cylinder. This projecting portion was only stem. Okay, this stem helps you to open the gas to allow the gas to flow by raising it with the key. If you open it anti-clockwise, it will open, and if you close it with the clockwise direction, it will close. Okay, so that is the mechanism of opening. But it is not the stem alone, it is the entire. So what is shown here is actually the front and back of the valve assembly. Shown here are the front and back of cylinder valve assembly. What are the parts you see in the front aspect? What is the part? What are the components you see in the back side?
Back
In
side
the
it is
front,
cone.
it
Back
has a
side we have
fuel index safety system.
back side we have port.
Front. This is the which is the front? This one or this one?
The one with the port is
This is the one with the border seal. Actually, it would be little black, but to differentiate, it is given white. So this is the one which is facing the cylinder. I mean the machine, so that the gas will flow. As I showed in the earlier picture, this is the nip opening for the. This will go and fit into that nipple-like portion, and gases will flow through that. And Bodak seal will be around that. This is not actually Bodak seal. This is the area to accommodate the Bodak seal in the valve assembly. And these are the two pins which will be, the two holes to fix it into the pins that is projecting from the hanger yoke assembly. So this will be fitted into the machine. This is the back side. This central depression, conical depression, is for that retaining screw to come in. And what is this? There is another screw-like thing which you will see here. What is that?
Pressure valve.
pressure.
That is the
Pressure
pressure
relief
relief valve. Very good. This is the valve stem with tightening nut at the top. This is the stem or the probe with the tightening nut at the top. Front side of the has got the port for gas outlet, below which are the holes for the pin index, pins to seated. Back side has got a depression for retaining screw and a safety relief valve for excess pressure. So this valve can maybe a spring loaded or a fusible plug or a made of wood metal which will melt and all these things which we'll see later. So this is a pressure relief valve. So front side you have two components actually. One is the gas outlet and the holes for the pins. And the top stem is there for on all sides, and at the back you have a retaining screw and the pressure relief valve. Identify this and name the parts.
Pressure gauge is there, sir.
Pressure gauge is the. So this component has been removed from the anesthesia machine, older model, and it has been displayed here.
Yoke assemblies.
Behind us, yoke assembly.
Huh?
The last part is yoke assembly, sir.
This part or this part?
That one, sir. That's it.
This one, where does it go?
No, sir.
So this has
It's
been removed from the hanger yoke assembly. Okay, this is the entry port. So whatever gases, when you open this stem, gases will flow and enter through this, and the pressure gauge will show the pressure that is present in the cylinder. If it is a full cylinder, it will go up to what pressure? How many psi of oxygen will be there?
2,200.
2000 psi. Very good. So this is the entry port which is connected to the hanger yoke assembly back. This side, this is screwed there, and gas will enter once you open the stem, and pressure gauge will read. What is this portion? After the pressure gauge assembly, what is this portion?
Pressure regulator, sir.
This is a pressure regulator or reducer. Earlier it was called pressure reducer. Later on, the name was changed to pressure regulator to reduce the PSI of 2000 to what pressure?
45 to 55, sir.
45 to 55 is the wall outlet pressure. Which comes
100
to
kilo.
400 kPa.
this reduces to 14 to 15 psi. Okay, pressure regulator reduces a pressure of 2000 produced by the cylinder to 14 psi or 15 psi. Similarly, if it's a direct pipeline supply, that will also be reduced to 14 to 15 because the pressure which should reach the flow meter assembly is only 14 to 15 psi. Please remember that. So whether it is 2000 psi directly coming from an attached cylinder or whether it is 40 to 50 psi coming from a central pipeline supply, this pressure regulator has to reduce the pressure to 14 to 15 psi, and these are the further connections going to the flow meter, and this is one going to the emergency outlet. Okay, the oxygen flush or the oxygen fail-safe alarm. So two connections will go from the pressure regulator. One will go to the flow meter, and so this is unit of anesthesia machine which consists of gas inlet, pressure gauge, pressure regulator, and downstream outlet. This portion is the downstream that is going to the flow meter or the emergency oxygen flush and other things. Okay. So what is shown in this and where is it used? This
Schrader probes for oxygen connection.
this is one, and this picture, this is a blue knob is written oxygen. Where is the Schrader probe you see? Probe earlier you saw it is all conical.
Pressure gauge is there, sir.
There are two pressure gauges. The Schrader probe carry a pressure gauge also. So this is called the two-stage oxygen pressure regulator for oxygen. Okay, usually these were used older days in the when the nowadays every part of the hospital, especially all the corporate hospitals or medical college hospitals, everywhere you see there is a central pipeline outlet for oxygen, suction, air, everything. But older days they never used to have pipeline for the ward or the even the ICUs did not have pipeline supply. So they used to use the large cylinders with this pressure regulator attached to that. So you can reduce the pressure to, if you want to use it for a ventilator, you can reduce it to 40 to 50 psi. And in case if you want to use it directly for oxygen mask or cannula, you can reduce it to 15 to 20 psi. So there are two regulators, and you can see two outlets which will go to the patient. Okay? And this is the probe which has to, the point where it has to be attached to the cylinder. Okay? And that is how, by turning this knob, you can adjust the pressure as you want it. So it is fitted to the B-type oxygen cylinders to reduce the cylinder pressure to desired level according to the patient condition. So this is this will give you an idea how this is connected. Okay? So this is the this is, anybody knows the name of this? This is to open the stem to allow the gas to flow here.
Cracking cylinder.
This is the wheel handle for opening the oxygen. So if you rotate it by holding it on the top, it will open the oxygen, and you can see the different pressure. One is got pressures of 1000, 2000, 3000, 4000, and another has got 100, 200, 300, 400 like that pounds per square inch, okay? or PSI rather. And this is the, instead of a plastic knob, it has got a lever like thing. By rotating that, you can adjust the pressure in both the two. Okay? So this is one of the very old equipment. I have just kept it in case some hospitals may still have this. This should not be taken by surprise by not knowing what they are for. Okay? What is shown here?
Various pin index.
Pin index safety
Index, very
system.
good, for various gases. So pin index of various gases. So what is the, can you tell me the number for various gases? This is also asked in the exam repeatedly.
Air is 1.5, nitrous oxide 2.5, oxygen 3.5, sir. Internox 7.
Internox is 7.
7, single, okay. So oxygen is 2.5, nitrous oxide is 3.5, air is 1.5, carbon dioxide is 1.6, and Internox is a single thing is number 7. What is 3.6? Which gas has got a pin index of 3 and 6?
Cyclopropanes.
Cyclopropane.
Carbon
So the formula of cyclopropane is 3H6. So you remember that as 3 and 6 as the cyclopropane index. What are the various sizes of cylinders, their capacities, pressure, and air weight? How cylinders are given names for according to
A
the
to
size?
J.
Huh?
A to J, sir.
They are given alphabetical numbers,
Alphabetical
in letters A to. So B is A types are very, very small cylinders. Now they have become obsolete, not used. B, D, E, F, G, H, N. These are all the things. And these are the various capacities. This is the pressure, and this is the weight. As you see, from B to M, the weight goes on increasing, which means H and M are the large cylinders which have a huge capacity. So the H cylinders are mainly used in the manifold room, which picture I showed in the earlier slide, or it used to be the G cylinder or M cylinder. These are the things that are used. Which type of cylinder is usually fitted in anesthesia machines?
E-type cylinders, sir.
E-type, very good. So it is the E-type cylinders mounted in anesthesia machine. If nitrous oxide pressure gauge shows 400 psi, how much gas is left in the cylinder? What will be the pressure in a full nitrous oxide cylinder when you start the case? Supposing you fit a full cylinder,
760.
open the stem,
760.
it will show 750 psi. Very good. And if supposing the pressure starts dropping and comes to 400 psi, what will be the amount of gas left in that? Why earlier nitrous oxide yoke assembly never had a pressure gauge?
It is not reliable for nitrous oxide, sir.
Why?
Because of the
Because it
supercritical
measures
temperature.
only the vapor pressure, not
One at
the.
a time, one at a time.
It is in the liquid form.
It is a liquid in
Because
the
It
It
is
is
in
in the liquid form. It has to vaporize and become a gas. So till the last drop of liquid nitrous oxide is there, it will show the same pressure. And then suddenly start decreasing when the last vapor has become gas and then it starts coming out. That time only it will start reducing the pressure. So people thought, why unnecessarily have a pressure gauge for that, which will be constantly showing only 750 until in the final stages. But later on, now you find all your machines have a pressure gauge for nitrous oxide also. Why? Why they have to change the concept? Okay, think over it. I'll tell you the answer later. So this is the volume of the cylinder when it is full is 1590 liters or roughly 1600 liters. Okay. So it will show 745 or 750 psi within also, but when it comes to 400 psi and the needle drops here, you can see the liquid or the gas form of nitrous oxide will be 136 liters. Okay. Until then, it will be showing the same pressure. So when the pressure roughly becomes half of the initial pressure, that means from 1600 liters, the gas will be only 136 liters. And this is because if a patient undergoing neurosurgery, you are using nitrous oxide. Nowadays, of course, the nitrous oxide is being condemned for usage and people have started using only medical air. But earlier, when they were using nitrous oxide, the plane of anesthesia will vary and there is a possibility the patient can become lighter. Similarly, in cardiac surgery also, there may be lighter plane of anesthesia. If you don't look at, if you do not know what is the pressure and how long the nitrous oxide cylinder will last, the patient is likely to receive a lighter mixture and become lighter in plane of anesthesia. That is the reason why they incorporated this. What is star weight?
empty weight of the cylinder, sir.
The weight of an empty cylinder, the weight of an empty container is referred to as star weight. What is filling ratio and what is the value for nitrous oxide and carbon dioxide?
So it is the ratio of weight of the liquid to be filled to the weight of the water it can hold, sir.
Okay. What is the value?
It's 0.6 for nitrous
0.75.
and carbon dioxide.
0.64 or 68 or 67? Is it the same for both the nitrous oxide
7.5.
and carbon dioxide or different for both?
It is same for both nitrous and
Yes.
carbon
Filling
dioxide.
ratio is the weight of liquid gas divided by the water capacity of the container. That is the, as you rightly said, the weight of the gas to be filled in the cylinder divided by the weight of the cylinder when it is filled with water, equal volumes of water. That is called the filling ratio. That is expressed in fractions or in percentage. What is the importance of this filling ratio? Why you should know about this filling ratio?
And all
This is
explosions,
to fill the cylinder with the oxygen.
Pardon? We are talking about nitrous oxide and carbon dioxide. Why you are talking about oxygen now?
to know the probability explosions, sir.
How does explosion will happen?
Sir, the liquid will vaporize at
That is the
different
first
temperatures,
concept
low
you should
temperature
say.
and hyper temperature.
The filling ratio is applicable to only gases which are stored in liquid form, whereas oxygen is stored as a gas. It is not stored only in liquid oxygen plant. It is stored as a liquid at a higher pressure. Whereas in the cylinders, portable cylinders which we use or even in the manifold room, the cylinders of oxygen have only gaseous form of oxygen. Whereas nitrous oxide and carbon dioxide both are stored in the liquid form which will vaporize to become gas before they are delivered out of the cylinder. So if you fill the cylinder up to its full capacity, there is no room for expansion of the gas. So the cylinder can explode. So to allow some space for the gas to form from the liquid, from the vapor, and get out of the cylinder, you need some space. So roughly you fill up only 0.67 or 67% capacity of the cylinder only to be filled, so that when you transport the cylinder to various ambient temperatures, for example, the cylinders may be manufactured in Chennai and it may be transported to the hottest part of Andhra Pradesh. And the ambient temperature in Andhra Pradesh in summer may be 42 degrees centigrade, whereas it may be only 35 degrees in Chennai. In that situation, the expansion of the gas will be more. So, and if there is no space for it to expand, the cylinder will explode. So, in order to safeguard that the cylinder does not explode because of the variation in ambient temperature, you don't fill it to the maximum capacity, but roughly fill it up only to about 67% of the capacity. And that is called the filling ratio. The point clear?
Yeah.
So it is
Yes,
about
sir.
68% for nitrous oxide and carbon dioxide. What information is available from the cylinder label?
The
How
type
the
of cylinder, the
Pressure,
identification
Date
of
of
the gas,
manufacturing, pressure test when it
Date
was
of
done.
loss checking.
date of validity,
So these are all the things: name of the contents, chemical symbol of the content, physical state, whether it is a gas or liquid, what is the total volume, whether it is flammable or non-flammable, whether service pressure of the cylinder, what is the service pressure of the cylinder size code, product license number, principal hazards of cylinder and its contents, date of hydraulic testing stamped on the cylinder. So these are all the points that you will get by looking at this portion where there will be a label or a collar in the neck of the cylinder. Identify this.
screw and the wheel on the top of the cylinders,
Hmm.
valve and the wheel.
That is the name for the bull nose and hand wheel valve cylinders. Okay, this is the attachment for the cylinders as I showed earlier. There are two types of attachments. Here for this you require a special key to rotate the stem. Whereas that the hand wheel valve, there is already a grip for you to hold that wheel and rotate it, and we can deliver the gas to that. What is shown in this picture?
So portable color-coded cylinders, sir.
cylinder pressure gauge, sir.
With the incorporated pressure gauge. Very good. Cylinder with integrated pressure gauges. What is the service pressure of the cylinder? Here it is written, the label you will find service pressure of the cylinder also. What is the service pressure of the cylinder?
Maximum
The
pressure
cylinders are
that can be
subjected
filled.
to
Maximum pressure that can be filled in the cylinder at 70 degree Fahrenheit, sir.
Service
cylinders are
pressure
subjected to
does not-
twice.
Which the cylinder may be filled at 70 degree Fahrenheit. How much more pressure they should withstand above the service pressure?
1.5 times.
Very good. They should 1.66 times the service pressure. They should be able to withstand. What periodic tests are done to check the safety or the strength of the cylinders?
Hydraulic test,
Impact test,
Hydraulic test,
bend test.
impact test,
Tensile
tensile test.
strength.
So many, they are tested at regular intervals with hydraulic, impact, and tensile. What is shown here?
Color-coded flow meters and series.
Flow meters.
Color coded
Flow
Flow meters.
meters and series
knobs and
arranged
flow
in series.
meters.
There are two parts of this picture. You can always see there is a A, there is a B. What does A show? What does B show?
A is
Single
single
flow,
flow meters,
flow and double flow.
twin flow meters. B.
Has only nitrous and oxygen and for high flow, sir. B has flow
B
meters
high
for
flow.
both
Here
high
you
flow
can
and
see
low flow.
nitrous oxide is graduated in smaller volumes also. Here up to 1 liter it is 100, 200, 300. Low volumes also is there.
For both low and high flow, it has only one flow meter, but
One
B
flow
has
It's a
two
tube
flow
and double
meters.
tube system.
A is single flow meter. B is dual.
Single and twin flow tubes flow meter. They are called single and twin flow tubes flow meters. So here there is only a single flow tube for both oxygen and nitrous oxide. Whereas here you have one tube for low flow, another tube for high flow for oxygen. Similarly for nitrous oxide and medical air, everything you have two flows. Okay. So this is the, what is the purpose of two flow tubes flow meter?
Low flow
We can
analysis.
access the
High
fine
flow and
graduations and
high
divisions.
flow and low flow, sir.
Huh?
High flow and low flow.
You require a low flow tube for low flow anesthesia. Okay? So two tube flow tubes are nowadays incorporated in the anesthesia workstation for facilitating low flow anesthesia. It is designed for providing low flow anesthesia because the first tube is divided in fractions up to only maximum 1 liter. Whereas the second tube, which starts from 1 liter and goes up to 10 or 12 liters. Okay? So, what is low flow anesthesia? What is
Deliver
the
less than
definition?
1.
Of 0.5 to 1 liters of flow, sir.
Is it
When the
described
fresh
in
gas
terms
flow
of
1
is
liter,
volume,
less
sir.
than the
Less
minute
than the
ventilation,
minute ventilation, sir.
minute ventilation or alveolar ventilation?
Alveolar
alveolar
ventilation.
ventilation.
Careful, because minute ventilation is different from alveolar ventilation. Okay, so any technique that employs a fresh gas flow that is less than alveolar ventilation can be classified as low flow anesthesia. What are the categories of fresh gas flow? How do you classify fresh gas flow?
Metabolic flow less than
High,
250
high
ml per
flow,
minute.
low flow, metabolic.
Minimum flow is 250 to 500 ml per minute. Medium flow is 500 to 1 liter. Less than 1 liter is low flow, and more than 1 to 2 liters is high flow, sir.
There
1
are
to 2 flow is medium flow.
all medium flow is 1 to 2 liters, low flow which is 500 to 1000, minimal flow which is 250 to 500, and metabolic flow about 250 ml. You cannot give less than 250 ml because we require 250 ml of
Oxygen
per
consumption.
minute. Okay, so the minimum you can give is only 250. And that too will be very risky. To give, you are likely to err on the side of hypoxemia. So you have to use minimal or low flow. So the definition of low flow comes under 500, half a liter to 1 liter maximum. How to estimate the uptake of individual agents like oxygen, nitrous oxide, and volatile anesthetics when you practice low flow anesthesia?
So the formula
What
3
formulas?
into 3 into fresh gas flow rate into diacetyl 8%.
It's the same for all three, or is there a different formula for each one?
It's a difference.
What are the different formulas? Any idea? So each one has got its own value. For oxygen, it is called simplified Brody formula, which is oxygen consumption is equal to 10 into kg, that is weight of the patient, ml per minute. Otherwise, it can be easily calculated as 3.5 into body weight. That's so many ml per minute. Okay, that is the way to calculate. Once you require 3.5 ml per kg per minute. So that is the way to calculate the oxygen uptake. It's called the simplified Brody formula. For nitrous oxide, you use what is called Severinger's formula, where because of the differential uptake, first minute uptake will be 1000 ml, 200 ml minute after 25 minutes. After 50 minutes, it will be reducing to 140 ml, and after 2 hours, it will reduce to 90 ml per minute. Because body size tissues will get slowly saturated with the drug, so the uptake will gradually reduce after the exposure. The initial uptake will be always higher. And for anesthetic agents, we use what is called Lewis formula, where fresh gas flow is equal to max frequency. So the factor that defines the inhalation concentration that is sufficient for unresponsive skin incision at Mach 1.3. So the blood gas partition coefficient, cardiac output, and time are all taken into that. And at least remember the names: Brody for oxygen, Severinger's for nitrous oxide, and Lewis formula for anesthetic inhalation agent. So this is how, even if you don't remember the details how to calculate, just remember the names. So in case examiner asks you, you can always answer that. Brody's formula for oxygen, nitrous oxide, Severinger's, and anesthetic inhalation, Lewis formula. Name the parts that have been marked or masked here.
Flow control knob,
Very good.
Bobbin thing is this.
Bobbin. You straight away jump to bobbin from here. There are so many things which have been marked here. See, actually, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things you have to identify. I have masked 10 parts which have been pointed. So this is a flow control knob or fluted knob. What is this?
Flow stop,
Flow
stop.
stop. Okay. What about this? This one,
Needle, sir.
needle, pin needle valve. Okay. What about this?
Gas inflow.
This is
Inlet.
gas inflow from the headline. Okay. This is the seat for that. What is this?
lower limit for bobbin,
This is the stopper for bobbin, lower limit. This is the bobbin. This is the upper
upper
stopper.
limit for bobbin.
This is the screw.
Manifold.
So you can see flow control knob, the valve stop here, the needle valve, oxygen inlet. This is called the valve seat. This is the float stopper. This is the float or the bobbin, the tapered float tube, the float stop for the upper one, and the top thing to prevent the gas escaping. Okay. What are the safety features incorporated in flow meters?
So they're color coded, touch sensitive. They're fluorescent and
Color-coded knobs
illuminate in
are
the
there.
dark.
Okay, the tubes are not color-coded. These are knobs
the
which you
knobs.
control to open and close. They are color-coded. They are different flutes. They are different to touch. Oxygen is the biggest fluted knob. The things are all small fluted. Now,
The fluorescent tubes which are illuminated in the dark.
They have anti-static material which prevents sticking of bobbin or float.
very
They
good.
have lower and the upper stopper so that the
prevent
bobbin will be
Bobbin does
from
not
coming
visible
fly out.
all the
Okay.
time.
Yeah. Providing stops at the full on or off position. Oxygen flow control knob is the largest and fluted for easy identification. And it projects more than the other knobs. Protective barrier around the control, minimize accidental changes in the settings. This is the protective barrier. You can see that this is a rod-like thing so that your hand does not touch the knob unnecessarily. So this is an effective barrier. And master and slave mechanism between oxygen and sulfate to prevent hypoxic mixture. And the tubes have anti-static coating preventing bobbin from sticking, and fluorescent plastic backdrop for visibility in darkness. Presence of independent auxiliary oxygen flow meter. This is a very important newer feature added in all the anesthesia machines. So even if the main flow meter fails, you can still have oxygen delivery through this oxygen. And downstream placement of oxygen flow tubes to prevent hypoxic mixture. So these are all the points that you have to remember for the safety features incorporated in flow meter. What is the most important goal before using anesthesia machine?
So machine checks.
Machine check. Only that before machine check.
Go back, sir.
Bag.
Ambu bag. Yes, key points. Miller anesthesia gives this. If there is any possibility that workstation or breathing circuit is a potential cause of difficulty with ventilation or oxygenation, switching to a self-inflating resuscitation bag is an appropriate decision. So ventilate the oxygenate first, troubleshoot later. This is the main important axiom that we all have to keep it in mind. So the most important part of the pre-use anesthesia workstation checkout procedure is verifying the presence of self-inflating resuscitation bag. This is the first and foremost thing. Now, can you trace the path of the gases, oxygen and other anesthetic agents from the point of delivery to the machine to the patient?
Starting from high pressure systems, sir, from the machines, from the cylinder,
Cylinder.
yoke assembly, pin index, yoke assembly, and crossing the pressure regulator.
So the first point is source of gas supply. Identify whether it is from wall outlet or from the cylinder attached and from the yoke assembly. This is the first thing we trace. Then check the high pressure reduced by pressure regulator before gases reach flow meters. That is the second stage. And oxygen dilute devices incorporated before the flow meters. And flow meter is the beginning of low pressure segment. Vaporizers fitted next to flow meters downstream of flow. And finally, gases and vapors are delivered through the common gas outlet at the atmospheric pressure. Okay? So these are all the various stages or steps through which the gas has to flow. How are pressure systems in anesthesia machine classified and what are the values?
High
High
pressure.
pressure, intermediate, and low pressure.
Get and low pressure system.
Medium, high pressure, intermediate pressure, and low pressure. So the high pressure system confined to cylinders in the primary sources of regulator is a 250 for oxygen or 40 feet straight away from pipeline. Intermediate begins with the pressure regulator cylinder supply at 45, included to pipeline source of 50-55 extends to meter. Low flow extends from flow control valves to common loop. What are the units of measurements of pressure? What is their correlation? How they are interconnected?
Then kilopascal.
One bar is 100 kilopascals, which is equal to 7.5 millimeters of mercury and 14 psi.
100 kilopascals is equal to 7.5 millimeters of mercury.
1 kilopascal, 7.5
kilopascal.
millimeters.
Okay. So there are PSI, pounds per square inch, PSIG, which is gauge pressure, PSIA, pounds per square inch absolute, and PSIG plus local atmospheric pressure is the way to calculate PSIA. Okay. And normally 100 kilopascals is equal to 1000 bar 160 millimeters of mercury or 1030 centimeters of water or 14.7 psi, which is equal to 1 atmosphere. So this is a equation which all of you should remember very well. So in kilopascals, bar 76 millimeters of mercury, centimeters of water, psi, and atmosphere. All these measurements are used 1, 2, 3, 4, 5, and 6 units are used for measuring the pressure. And the relationship between each one is very important. Especially, as rightly said, 1 kilopascal will be roughly 7.6 millimeters of mercury. So nowadays, many textbooks give the BP reading also in kilopascals. So to convert that from kilopascals to millimeters of mercury, examiners usually ask this question: how do you convert the kilopascal into millimeter? So 1 kilopascal is equal to 7.5 roughly, and we can calculate if it is given in kilopascal. What is the effect of altered barometric pressure on delivered concentration of volatile agents?
As the altitude increases, the partial
The ambient
pressure of
pressure, will
gas
it
is
come down or go up? At high altitudes, the ambient pressure, will it be low or high or normal?
It will be low, sir.
Low, sir.
Lower than sea
low.
level. So when there is a lower pressure, what will happen to the output concentration? Will it increase or decrease?
It will
Increase in
increase.
the volume
Increases.
percent
Increase in the concentration of
released
volatile
from
agent.
the increases the volume percent of vaporizer.
So the effects of altered barometric pressure, normal dial setting multiplied by 760 divided by the ambient pressure. For example, if the ambient pressure was only 630 millimeters of mercury instead of 760 at sea level, if isoflurane is set at 1%, then 760 divided by 630, its actual output will be 1.2%. Okay? So higher the altitude where the ambient pressure is low, the dial setting will deliver greater percentage of the volatile anesthetic agent. So the set concentration is 1%, delivered concentration is 1.2. Is it to be worried? But partial pressure of 1% isoflurane at 760 is 7.6 millimeter. And partial pressure at even 630, because it is delivering 1.3, will be 760, 7.6 mm. So partial pressure will not change despite the fact that the ambient pressure is low. So that is the point that you have to remember. So dial setting need not be altered to suit higher altitude, even though the concentration output will be more, because the ambient pressure is low. The partial pressure of the volatile agent is the one which determines the uptake. So it will be the same. So if the examiner asks you, you have to have a different type of vaporizer for higher altitude like Kodaikanal or Ooty where anesthesia is given. It's not necessary. You can use the same vaporizer that you are using sea level. The point clear?
Yes, sir.
So even though output concentration by percentage increases, the partial pressure will remain same because of the lower ambient pressure there. Identify the person and the equipment.
Is Edmund
Boils
Boyle.
are
This Henry Edmund Gaskin
Edmund
Boyle.
Boyle.
That is his name. What is this picture? Where
Boyle
you can
is a
see they have used spirit lamp and all these things in anesthesia machine. Will you allow it nowadays?
no, sir.
No,
What is the purpose of this spirit lamp?
For heating up the volatile
Heating
agents.
the volatile anesthetic agent. Okay. They never knew that it can Only after explosion occurred, they understood that they have not used this. And this is the basic design of anesthesia machine designed by this particular man. So Henry Edmund Gaskin Boyle, first prototype of anesthesia machine is the, you see bag is attached here, face mask close to that, and the gas delivery, everything is there, and the cylinder with the valve, everything attached to that. And this is the modified later version, first type prototype of anesthesia machine. What are the achievements of Boyle? It's one of the theory questions also. As a short note question, they ask about famous personalities in anesthesia. So there are a lot of achievements this man has made. Anesthesia machine itself synonymously with his name. Even nowadays, older generation anesthetists like that, we'll say, where is the Boyle's machine? We don't ask where is the GE workstation or Apollo workstation or ISIS workstation. We still call it Boyle's machine only. So what are the other achievements you can talk about? Okay, Boyle worked as St. Bartholomew's Hospital throughout his career, eventually retiring as a consulting anesthetist in 1939. So in this way, I can equate myself with Boyle because I also worked consistently in only one institution, namely Stanley Medical College for 36 years and retired. So I can compare myself with Boyle even though I have not done anything great. Second thing is he developed his own continuous flow machines which included cylinders for gases and a boil bottle to vaporize dilute ether. And until recently, anesthesia machine was often referred to as Boyle's machine in honor of his contribution. He later introduced a gag called Boyle-Davis gag with his ENT surgeon friend Davis. Both of them designed the tonsillectomy gag, which later became known as Boyle-Davis gag. And he played a key role in the development of endotracheal anesthesia and greatly improved the anesthetic safety. And on the academic side, he was the president of the section of anesthetists of Royal Society of Medicine in 1923. And he is the founding member of Association of Anesthetists of Great Britain and Ireland. One of the, just like our Indian Society of Anesthesia, it was the Anesthesia Society for Great Britain and Ireland. And he was the first examiner for diploma in anesthesia examination conducted by the Dental Medical Council or the fellowship Royal College of Anesthetists conducted the first diploma anesthesia was first started, then only fellowship in anesthesia was started. FRCA was started later. And he was the examiner for the diploma in anesthesia. And he's also published a textbook called Practical Anesthetics. So much of achievements for him. What is critical temperature and critical pressure?
The temperature
The
above
temperature.
which it cannot be liquefied is critical temperature, sir.
What is critical pressure?
The pressure that is required to convert the vapor to
Gas
liquid.
into liquid. The critical temperature of a substance is the temperature at and above which vapor of the substance cannot be liquefied no matter how much pressure is applied. And critical pressure of a substance is the pressure required to liquefy a gas at its critical temperature. Okay? What is medical air? Nowadays, all of you are using air and oxygen combination quite frequently. So you must know what should be the quality, what is the definition of medical air. Any conditions? Because you have air everywhere. The air that is being used by the orthopedic surgeons or the neurosurgeons for their instrumentation, that is not purified, isn't it? So medical air needs to be more pure. So air that has no detectable liquid hydrocarbons For less than 25 parts per million gaseous hydrocarbons, less than 5 milligram of cubic millimeter of particulates of 1 micron size or greater at normal atmospheric pressure, and a dew point at 50 psi gauge pressure of less than 4 degrees centigrade. And low levels of nitric oxide found in ambient air may improve oxygenation in ventilated patients. So that may be permitted to some extent. But other things, there should be no liquid hydrocarbons, there should be no particulate matters more than 1 micron size. These are the two things which are very important. How will you calculate the percentage of oxygen while you are using a mixture of oxygen and air? Supposing you use 2 liters of oxygen and 2 liters of medical air for anesthetizing a patient and general anesthesia. What is the percentage of oxygen you will be supplying to the patient?
So it is 0.2 into 2 liters plus 21.21% into liters of air, sir.
0.2 is in the air, but you are giving
1
100%
into
oxygen.
liters of, it is 1 into liters of oxygen plus 0.21 into liters of air.
So tell me roughly, if you use 2 liters oxygen 100% and 2 liters air, how much percentage of oxygen will you deliver to the patient?
50%, sir.
50%, sir.
Shall we see the formula? So oxygen concentration is equal to 100 into 1 into oxygen per liters per minute plus 0.21 into air per liters per minute divided by oxygen, total oxygen and air combination. So the example, supposing you use 2 liters of oxygen and 2 liters of air. Now this is 100 multiplied by, this is 100% oxygen and you are using 2 liters. So 1 into 2 is 2 plus add 0.21% in air and 2 liters in air, 2 liters of air you are using. So what happens is you get 2 plus 0.42. Remember this? So this is multiplied by 100, it becomes 242. And this has to be divided by the total volume. So what you get is 60.5% and not 50%. Okay? So you get a higher percentage of that. It is not just you are cutting the 100% into 50% because the air also contains 0.21% oxygen. That also has to be taken into consideration. So if you are using some non-oxygen containing gas, then it will become 50% if you are using equal volumes. But if you are using air, you will definitely get a higher percent. So you must remember this formula. You can calculate it according to what you are using, whether 1 liter or 2 liters or 250 liters, whichever ratio you are using. If you are using less oxygen and more air, will the percentage come down or it will go up? Because you have to take into consideration the total volume you are delivering also. Okay, so it will come down if you are using more air and less oxygen. For example, if you use 2 liters of oxygen and 3 liters of air, then it will become 2 plus 3 5. So the whole thing has to be, this will become slightly higher, 2.63 it will become. So 263 divided by 5, it will become 50, roughly about 50%. So if you want to give lesser oxygen percentage, you have to increase the amount of air that you are using. If you want to give higher percentage of oxygen, you have to use lesser air, then you will get a higher. So remember at least that basically. What is adiabatic and Joule-Thomson effect? People pronounce it as adiabatic or adiabatic. Joule-Thomson effects. Prof silence. Right. Okay. Adiabatic change and Joule-Thomson effect. When gas is subjected to sudden compression, the heat energy is produced rapidly, and the reverse occurs when there is a sudden expansion. There is no exchange of energy with the surroundings. This is what is called adiabatic or adiabatic change. In Joule-Thomson effect, when the gas is allowed to escape through a narrow opening, there is a sudden temperature drop. Where will you see this effect? Joule-Thomson effect. When a gas is allowed to escape through a narrow opening, there is a sudden temperature drop at the point of release of gas.
Venturi effect.
Venturi. What has the Venturi got to do with that?
Leaks, sir.
This you will see in the olden days when we are using only cylinders mounted on the anesthesia machine. We used to commonly see this in the nitrous oxide cylinders because nitrous oxide is a vapor and it takes the temperature from the cylinder for evaporation into gas. And when this gas comes out through this small opening to go into the machine, the neck and body portion, upper portion of the cylinder, after some time it will form a dew. It will form, even icicles will be formed because it will cool down so much, it will draw the water vapor in the surrounding ambient air of the cylinder, and it will form a white frost-like thing, especially in the AC ambient temperature of the theater. You can see the nitrous oxide cylinder becoming coated with ice particles. That is what is called the Joule-Thomson effect. And the adiabatic effect is important because that is the reason why you have to open the cylinders if you are going to use with a key very, very slowly. If you rotate the stem very fast and release the cylinder, this heat exchange will happen. There is a chance of explosion. So whenever there is a need to open the cylinders mounted on the anesthesia machine, to prevent explosion, we must open the cylinders very slowly. That is the importance of this adiabatic change and the Joule-Thomson effect. What are the features of oxygen flush valve?
It provides
It delivers 30 to 60
100%
liters per
oxygen
minute.
and
Delivers
oxygen. 30 to 60 liters
intermediate
per
pressure level.
100% oxygen.
Peak flow rate.
At high pressure values.
High pressure, correct. But what is the, how many liters volume it will deliver if you
35 to
activate
75
30
liters
to
per minute.
70
35 to
liters per
75
minute.
liters? Very good. So this is oxygen from pipeline inlet or cylinder pressure regulator and directs high unmetered flow to common gas outlet downstream of the vaporizer. And machine standard requires that the flow be between 35 to 75 liters per minute. The single purpose self-closing device designed to minimize or unintentional activation labeled oxygen plus. That is the symbol that is given. The hazards may be, it may cause barotrauma because it is delivered at 45 psi and not 14 to 15 like you get it from flow meter. And dilution of inhaled anesthetic gases can happen. Accidental activation can make a tight bag. Silently, sometimes the oxygen. This is the oxygen flush here. This is a push type button. And if this button is not fully released, you will get a slow stream of oxygen going all the time. And that may cause a tight bag situation. And internal leakage also can happen, and the flush may get stuck in some positions by repeated use. So these are all the features of that. What are the some unique features of oxygen flush? These are all regular features.
They can operate even when it is off, since they are located in the upstream.
So flush valves for gases other than oxygen is not permitted. So we have only flush valve only for oxygen. The oxygen flush can be activated regardless of whether the machine is turned on or off. Even when your workstation is in off position with the power supply, it can still work. And pressure delivered is at 60 psi pounds. That is why barotrauma is very common. So unless really needed, we should not use this. Okay? So three things. It is unique for oxygen, and it can work even when the machine is not on, and it is delivered at 60 psi pressure. Now there are two oxygen flush switches are shown. So what is the difference between these two?
It is located bit inside, sir, so that there won't be accidental activation of the oxygen.
Accidental activation is prevented by a ridge or a guard that is present here. Whereas here it is not present. This is the ridge. So this is little inside, sunken inside the ridge. So accidental activation is not possible. Whereas this is flush to the surface. So by the hand can touch this and activate that. Where is the oxygen flush in this picture? It's an older type of machine. Where is the oxygen flush activator or switch here? How many of you have had an opportunity to see and use these machines nowadays?
Yes, sir. It's in green color.
Huh?
It is in front, sir. The oxygen flush one is presented.
So in this picture, can you tell me exactly where is that oxygen flush activator? So I am tracing it. These are pressure gauges. This is the flow meter. This is the vaporizer. This is the vaporizer. This is the common gas outlet. Where is the
To
oxygen
the
flush activator?
common gas outlet.
So this is the
That on-off knob, sir.
this we have to rotate down or up. In the up position it is off. The down position it will be on. So you can see this close up view. So this is off position. You rotate it downwards, it will become on. And immediately high flow gases will come. And there is a dial here. Can you see this? There is a pointer here. Have any of you noticed this machine? What is the purpose of this dial or the switch? Okay, tell me later. Describe what is shown here.
Halogen vaporizer.
The Goldman Hamilton vaporizer. Correct.
Vaporizer.
Somebody is mumbling. Should be loud. Okay. This is a Goldman vaporizer. It is a variable bypass, incomplete vaporization, flow over without which low resistance inside the circuit usage can be done, non-agent specific, but by practice usually used for only halogen, but you can use any agent you want. No temperature compensation, no interlocks, glass bowl originally an automatic fuel filter chamber. It is economical if taken from place to place. You can carry it because it's portable. Used inside the circuit. Output decreased due to cooling after induction. Patient hyperventilation is highlight the cost increased output. And Mark 1, the model in 1959, it easily bumped 3 positions. It is the on and off lever. By rotating it, you can use the off position. Then there are 1, 2, 3, and 4 positions which you can open. So variable bypass. The fresh gas flow will come through and take the vapor and come out. And in Mark 3, it was changed to lever to click. So this is the modification that was done. How to use Goldman vaporizer inside the circle system? Many of you would not know. I just thought this picture will help you to see. So this is the Goldman vaporizer attached to the inspiratory limb of the circle system. Okay. So this is the inspiratory limb. This is the expiratory limb. This is the canister with the soda lime. So this is attached to the inspiratory limb. And you can fill it with halothane and open the lever. And the advantages of using the PIC, vaporizer inside the circuit system. What are the advantages? When you use circle system with the vaporizer inside the circuit system, what advantages are gained? In those days, one of our examiners used to ask us in the exam, you have only 5 ml of halothane and you have to do a laparatomy case for 2.5 hours. How will you manage that entire surgery with 5 ml of halothane? Then the answer for that is to use the Goldman vaporizer inside the circuit, because the exhaled gas is going to be recycled here. So you can keep the vaporizer in first position and the 5 ml will get slowly evaporated over a period of 2 to 2.5 hours. And because the exhaled gas is circulated again and patient inhales that, he will receive adequate of the drug also. Okay, so that was the answer that was expected out of it. And this is just for you to see a historical interest. This is, you can see there is a ether attached to the, which is also included in the breathing circuit. This is a circuit system, inspiratory, expiratory limb. This is a pop-off valve. Ether canister is there, which is in off position. And you can see soda lime also has got a dial. So you can switch off soda lime and use only when required. So which agent you should not use soda lime? Which older one-time anesthetic agent, it should not be used in the presence of soda lime.
Ether, sir.
Ether, they are using it here. Both. There was another popular agent like ether.
Trilene, sir.
Trichloroethylene or trilene. Yes. Trilene, if you use it in the presence of soda lime, what can happen to the patient?
It causes neurotoxicity.
What is the name of the neurotoxin that is produced by the reaction of trilene with soda lime?
Trilene, sir.
It's called phosgene. Phosgene. Phosgene, it's a neurotoxin. Okay? The patient will have a neurological depression. He will not come out of anesthesia at all. So trilene should not be used for in the presence of soda lime. And in the earlier picture, I asked you the question, what is the dial-like thing that is close to the oxygen plus? It was called trilene lock in the older machines. So if you switch over to closed circuit from open circuit, the lever of trilene vaporizer that will not be operable. Okay, it will be stuck in off position. You cannot open the trilene vaporizer at all. So that was the safety feature incorporated very, very long back. So the choice between semi-open and closed circuits, breathing system incorporated a lock for preventing operation of the trilene vapor in the older machines. Okay. So it was also called trilene lock or the switch from open to close method of the circuit system. I'll show you a picture later on. So this is an older model of circuit system. Temperature inside the circuit facility to include or exclude soda lime canister also. This is just for making a little bit of tidbits, not from the exam point of view. What is link 25 proportion limiting control system?
which prevents
Connects
the
oxygen and
hypoxic mixture
nitrogen.
delivering to the patient.
Guarantees delivery of minimum 25%
25% of oxygen.
Okay, that is the main thing. So this is the picture to show how it is being done. So we have two sprockets, one for 14 sprocket wheel for nitrous oxide and 28 sprocket wheel for oxygen. So rotation will reduce. So this is present in Omega model machines. The purely mechanical system. A chain links nitrous oxide and oxygen flow control knobs and allows either to be adjusted independently, yet automatically intercedes to maintain a minimum of 1:3 ratio of oxygen to nitrous oxide. So always you will get 25% out of the 100% that you use. You can use 75% nitrous oxide, but still get 25% oxygen. This is what is this shown here, and how does this work?
Master slave mechanism, sir.
What mechanism?
Oxygen ratio monitor.
Ratio, oxygen ratio control. It's all. It's
Yes,
in the Draeger machine. It's called the oxygen ratio control hypoxic guard system found in previous GS machine also. So the resistors here, there are resistors in the flow meter which generate back pressure on control diaphragm. This is the control diaphragm for oxygen nitrous oxide. And in proportion to oxygen nitrous oxide flow. So SORC guarantees a minimum of FiO2 of 25% by limiting nitrous oxide flow. So when hypoxic guard systems, when can hypoxic guard systems permit hypoxic mixtures? Even though they are all incorporated to prevent hypoxic delivery of mixture, what conditions can still allow hypoxic mixture to be delivered in the presence of a hypoxic guard system?
The flow meter is damaged or broken.
Oxygen
When the
delivery
oxygen
is
is
less
not
than
present in the
consumption by the
downstream.
patient, the fresh gas flow, number one. Then strong supply gas in oxygen pipeline or cylinder. Defective pneumatic, mechanical or electronic components. If leaks exist downstream of flow control valves. If a third inert gas like helium is used. So in all these conditions, despite having a hypoxic guard system, still you can deliver a hypoxic mixture. So you require oxygen delivery more than what is required, 250 ml per minute. It's the minimum required oxygen amount. So if that is not metabolic flow, if you give less than that, patient can still receive hypoxia, wrong supply, effective parts leak, or the gas usage. What is shown here and what are its features? Again, these are the things which you will see only in the older machines. So I'm purposely giving all these things because in some centers they may just to bully you keep all these old machines because you are all nowadays used to only workstations and still keep these things too.
So Ritchie whistle, sir.
Huh?
Ritchie whistle.
This is the pop-off valve. Okay, this is called the pressure releasing or pop-off valve present in the back bar of the situated downstream of evaporators on the back bar or the near common gas outlet. Prevents high pressure buildup inside the machine. And when the preset pressure exceeds, it opens to vent the gases to atmosphere. So what is the pressure at which this valve should open? It is preset to prevent high pressure development inside the circuit.
25 psi.
It's too low. If we open, the back bar pressure increase 35 kilopascals. And what is shown here?
Inspiratory and expiratory valve.
Directional valves.
Three valves in the circle system. Unidirectional check valve. Okay. What are the features of common gas outlet? Now here you can see the common gas outlet. This is all of you should be familiar with this area of the workstations. This is the guarded oxygen flush. This is the
Master
switch for switching from non-heating circle system, and this is the common gas outlet. What are the features of the common gas outlet? What is the diameter of the common gas outlet? So receives all gases and vapors from the machine and delivers the mixture to the breathing system. That is the purpose of this common gas outlet, number one. Some outlets have 15 mm female slip joint fitting with a coaxial 22 mm male connector. These two numbers are very, very common in all the breathing systems adapters. So there will be a 15 mm female joint with a 22 mm male connector. So this will be fitting tightly without the leakage or slippage. What is the pressure of delivered gas mixture at the common gas outlet?
5 to 8 psi, sir.
Very good. It is about 5 to 8 psi. What is the type of flow in flow meters at low and high flows? What factors determine that?
At low flows, it is dependent on the viscosity, and at high flows, it is dependent on density, sir.
Okay, but what type of flow?
At low flow, it is
Laminar
laminar, and
and
at high flow, it is
turbulent.
turbulent.
Turbulent flow.
Answer. The first part is the laminar at low flow and the turbulent at high flow, and it is the viscosity and density which are the controlling factors. At low flow gas is laminar because the gas flows around the bobbin is tubular. It is because the length of the tube is more than the diameter. And viscosity is an important factor for this. At high flow, gas is turbulent because the gas flow around the bobbin is passing through orifice where diameter is more than the length. And density is an important factor for that. So this is the picture to show the tube effect and the orifice effect. When the gas is at a low flow and the bobbin is at the bottom of the flow meter tube, you have a tube effect where the diameter and the length is more than the diameter. Okay? So the length is more than the diameter. Whereas at high flow, it behaves like an orifice where diameter is more than the length. So this is the explanation for it. Which law is applied to show the relationship between laminar flow and viscosity, and write the equation?
Hagen-Poiseuille's equation.
Hagen-Poiseuille's law.
Again, actually it is to be pronounced as Hagen-Poiseuille law. Okay, even though it is written as Poiseuille, it will be pronounced as Hagen-Poiseuille law, and it is Q is equal to 5 PR to the power of 4 by 8 NL. And what factors are involved in turbulent flow, and what is the unit of its measurement?
Density, sir, it is measured. I mean, Graham's law is applied for its.
What is the unit of measurement of this turbulence?
Reynolds number, sir.
Reynolds number, very good. Factors involved are V for velocity of fluid, T for density, T for diameter, viscosity. So this is written as RE is Reynolds number, TVD by U, which is called Reynolds number. What is Reynolds number and its importance?
If it is
Most laminar turbulent flow.
What is
it is
the
less
value?
than 2000. If it is more than 2000, then it is turbulent flows.
Turbulent. Less than 2000, it is laminar, correct?
Laminar.
Any other unique feature of this Reynolds number? Does it have any unit of measurement? like millimeters of mercury,
It
centimeters
has
of
no
mercury.
units, sir.
It has no dimensions. Okay, it's a dimensionless number. Can you give another some examples of dimensionless number used in anesthesia? Does pH have a unit of measurement?
No, sir.
Does this value have a unit of measurement?
No, sir.
These are all examples. Okay, Reynolds number is a dimensionless number. Values more than 2000 means it will be turbulent flow. Value less than 2000 means it will be laminar flow. It's shown here. Flow
Flow
meters.
meters.
Very easy answer. That type of flow meter.
Flow meters.
Twin
This
type.
is single flow
Flow
meter.
meters.
So constant pressure variable orifice flow meters, also called the torque meter. This is called the two tube design, and this is called the dual taper design. Okay. When you have a single tube, as shown in the earlier picture, you can still have flow from point 400 ml, 600 ml, 800 ml, 1000 ml, then 2 liters, 3 liters like that. So this is called the dual taper. Here at the low flow, it is a uniform tapering. Suddenly it becomes very wide. Whereas here, for a low flow, you have a similar type of tube, and then there is a connecting tube in series, then there is a higher flow tube. So this is called the two tube design and the dual taper design. What is flow meter tube called? What is the
Torch
material
tubes.
used? This is a torch tube. Already answer is given here. What is the material used in making it? Is it a glass?
Silicate.
Polypyrene.
Pyrex glass.
The borosilicate. Okay, the borosilicate. What is the purpose of single and double tube, double tapered tubes? Already we have seen that when
High
there are
flow, no.
separate flow meter tubes for low flows and high flows for the same gas, when the tubes are single tapered. That is single tapered means only one type of tapering. Whereas there is a single tube for the gas, then there is a double taper. So this is the double or dual taper. How does the bobbin rotate in the gas flows? All of you are seeing the bobbins every day, isn't it?
Yes, sir.
Yes,
Yes,
so
sir.
do you have electronic flow meters or common bobbin type flow
We have
meters?
both, sir.
Both, sir.
Both. Very good. So if you have seen bobbin, how does it rotate? Bobbin rotates because of the slots present at the top of it. Okay. So I am showing you a few types of bobbins. And you name them. These are all the slots through which when the gas goes, it rotates the bobbin. But there are older versions. There are 4 types of bobbin shown here. Do you know the names? This you can easily say from the.
Ball type, sir.
This is a ball type. Very good. This looks like a ball. This is
That is non-rotating type.
non-rotating. This is
It is skirted and tapered.
so it is wearing a skirt here. So this is skirted. This is non-skirted. What is this central depression?
That is a fluorescent.
It will have a fluorescent coating so that you can see it in darkness also, whether the bobbin is floating and rotating. Okay. So this is the common type that we see. So ball type, non-rotating type, skirted type, and non-skirted type. Okay. These are the various types of bobbin. What is shown here and what are the features?
Auxiliary ports.
Auxiliary
Auxiliary
for
Air and oxygen.
air
air
and
and
oxygen.
oxygen.
So the outlet also. So this will be air auxiliary flow meter, this is the oxygen auxiliary flow meter, and these are the outlets for that. Very good. So what are the features of that?
It works even when the machine is
The
on or
machine
off,
is off.
like
Ah.
the oxygen flush.
Okay. So it can work even when the machine is not on. Okay.
Maximum flows up to
So
10 liters per minute.
self-contained flow meter with its own flow control valve and flow indicator and outlet. Okay. Short tube with maximum flow of 10 liters per minute. It is usually on the left side of the machine. Can be used to supply oxygen to patients without turning on the machine. And older machines, they work on pipeline supply. Now the newer works on both cylinder and pipeline. These are all the features. What is shown here and why is it done? Are you able to see this picture and the arrow marks and all these things?
Yes, sir.
Now, what is being connected? What is this?
Gas outlets here.
Common gas outlet. So, common gas outlet, there is an adapter with a tube. It is connected to what is this?
This is flow
Oxygen
meter.
flow meter, which you use in a normal for delivering gases to the patient. Okay, so that has been adapted and given to this. Now, this arrow mark, they are showing. What is this arrow mark pointing to?
It is showing leaks, sir.
Is the bobbin going up or not? The
Bobbin
bobbin
going
is
up.
bobbing.
Oxygen
up.
is on.
It is going up. And they are showing the oxygen
Oxygen knob.
knob. Is the oxygen flowing here?
No, sir.
No, sir.
No. And what about this arrow? What is it showing? Is it showing 0 or it's showing some percentage?
93.
It is showing 93%. So what does it mean? Oxygen
There is an
knob is
oxygen
not
Getting
leak from the
coated.
common gas.
huh?
Oxygen leak from the common gas outlet.
Flow meter connected to the common gas outlet to quantify the internal leak. Okay? So there is some leak occurring, so it is flowing through this, and you are able to see the flow there, and you can see this is the what is transitional or hybrid flow meter.
The electronic flow meter.
Both electronic and pneumatic.
Graphic. They display the graphic bar chart. Instead of
So the
flow
answers
tubes,
together, you get the
have a
total answer. Each one of you is answering part. So if all the parts are put together, you get the total answer. It's a transitional. In a transflow is mechanically controlled by the needle valve and electronically displayed by bar graph on computer screen. That is what is happening here. You can see this is the control knob for needle valve, and you get the bar graphs for the display. Instead of the tube with the bobbin, you get the display in electronic. Okay. So there's a needle valve, so flow can be generated even without electric power, and flows are captured and displayed electronically. Thus, electronic flow meters allow automated anesthesia record keepers to chart fresh gas flows. That is the idea of having a hybrid flow meter. What are the oxygen failure safety features? Earlier
Sir,
we saw only the proportionate system of delivering gases, but if the oxygen totally fails, what are all the safety features to indicate that there is a total lack of oxygen?
Oxygen failure alarms.
Alarms are there, very good.
Oxygen ratio monitor and control, sir.
So there can be pressure sensor set off valve and oxygen failure protection device. So this is pressure sensor shut-off valve is based on the threshold principle. It will immediately cut off nitrous oxide supply when oxygen pressure falls below 25 psi. Okay? And the oxygen pressurizes and holds open shut-off valve that interrupts the supply of nitrous oxide and other gases if oxygen pressure is less than the threshold setting. In oxygen failure protection devices based on the proportioning principle, gas loaded regulator is there. So when oxygen pressure decreases, there is a proportional decrease in nitrous oxide supply to completely cut off at 12 psi. Here it is 25, here it is 12 psi. Mode of operation is oxygen pressure regulator, primary regulator, control secondary or slave regulator located on nitrous oxide line. What is the mechanism in Datex Omega machine called for this oxygen failure and how does it work?
This mechanical type of with a bellow.
Shut-off valve. What is called the oxygen line fell to 20 psi. The flow of all other gases were shut off. Also, Omega used the second stage oxygen pressure regulation. How the whole thing works. When the oxygen supply pressure is 50 psi, it also allows the nitrous oxide to go. 50 psi, it reduces the nitrous pressure also to 25. When there is a 0 psi oxygen supply pressure, nitrous oxide is totally cut off. So that's how the system shows. Oxygen failure protection device that responds proportionally. What audible alarms are used and how they work to indicate oxygen failure? The name for that
Ritchie whistle, sir.
Ritchie vessel is one. There is another name also for another type or make called Bowman's whistle. Okay? And where else we hear the name Bowman?
Kidney, nephron, sir.
Kidney
Bowman's capsule.
Bowman's capsule. Okay, so the machine standard specifies that whenever oxygen supply pressure falls below manufacturer specified, that is usually 30 psi, a medium priority alarm shall blow within 5 seconds. The electronic alarm, a pressure operated electric switch operates the alarm. In Omega, it is 28 psi, in Draeger 30 to 37 psi. A pneumatic alarm, also known as Bowman's whistle, uses a pressurized canister that is filled with oxygen when the anesthesia machine is turned on. When the oxygen pressure starts falling below a certain level, the alarm directs a stream of oxygen that is there in the container or canister to go out through a hole which causes the whistle sound. And it should happen, and it should, how long that whistle should continue? Minimum 15 to 20 seconds, okay, so that it can be identified. This is the Link 25 system. What are the hypoxic prevention devices in anesthesia machine? This is another repetition of that thing. What is mandatory minimum oxygen flow?
It's
21%.
200 ml.
250 ml.
21%.
50 to 250 ml of oxygen flow before other gases flow. Machines activate an alarm if oxygen flow goes beyond a certain minimum. And there is also a minimum oxygen ratio used to protect against operator selection delivery of mixture. And mechanical linkage, that is the Link 25 system. These are all the hypoxia prevention devices. And flow control valves are adjusted so that 25% of oxygen concentration is always given to the patient, minimum 25%, and alarms are there. And oxygen ratio monitor again with repetition, so I will just skip through that. This is a very old type of anesthesia machine, which many of you would not have seen. So what is the role of back bar in these machines?
It is to
hold the flow meter and the vaporizer, sir.
So it is all fixed in the back bar only. The flow meter assembly, the two vaporizers, the heater and trilene, all these things. This is what I told you. This is called the trilene lock. When you this arrow mark showing. So if you keep this in position, it is an open position where you can use lever of the trilene also. But once it is switched to this closed position, this trilene lever cannot be operated. It cannot be lifted. And this is the oxygen flush. The semi-automatic basis, either up or down, it is in the off position. So part of the frame of Boyle's machine, which supports rotameter, vaporizer, and other accessories. There are two metal rods in the back bar. Flow meters and vaporizers are connected with each other and then bolted to the back bar. Now, describe the flow meter assembly shown here in this case. This is again a very old machine, so for the sake of not being surprised when some hospitals have these machines and some examiners want to keep it in the exam and test your knowledge, not to give you more marks if you answer all the current patient questions. They may teach you by asking the historical actually machines parts also.
It has oxygen, air, and nitrous oxide flow meters, where oxygen is separated from the other two flow meters.
Here.
Second
Yellow color.
Second one is like no knob at all. One is it is a silver tube. It is not a flow tube. There is no control knob here. And this is orange color knob, not air color. These are all standard color codes. Oxygen white and nitrous oxide blue. But this is orange color. It's not
cyclopropane, sir.
color. Cyclopropane, excellent. And what is this for? This tube which has been dummied.
Yes, sir. No.
Carbon dioxide. In those days, they used to have oxygen, carbon dioxide, cyclopropane, and nitrous oxide. Because they thought carbon dioxide is a respiratory stimulant. So they, at the end of general anesthesia, when patients are usually depressed, they thought by giving carbon dioxide to the patient, they can stimulate the respiratory center to make the patient breathe more effectively. Because most of the surgeries were done under spontaneous ventilation. So to stimulate the brain, they used to respiratory center, they used carbon dioxide. Then they found they are producing carbon dioxide narcosis and patient is becoming more deeper rather than waking up. So they dummied it and they stopped using that. But other gases they are using. So this is a very, very old type machine where we had one such machine in our Stanley, which was routinely kept in the exam, and the examiners are very fond of asking this color coding knob for cyclopropane. So it has three flow tubes and their control knobs. They are for oxygen, nitrous oxide, and cyclopropane. The one flow tube which is made dummy may have been used for carbon dioxide. What is shown here and what is unique about it?
Anesthesia vaporizers.
Vaporizer, CO, fluorine, and this.
Fluorine vaporizer, modern vaporizers are there. But what is the peculiarity about it?
Systems.
They have interlocking. You can use shown or the vaporizers for fluorine and fluorine. They are interlocked so that they can be used only one at a time. You can't use. Why this has been incorporated? Next question I think comes. What is the purpose of interlocking and how was it in older models?
Interlocking prevents from opening the more than one vaporizer cannot be opened at the
I
same
am
time.
asking why that is needed. What is the need for interlocking and preventing opening? Those days, we can open heater and trialing simultaneously. If you are using open circuit, patient is breathing spontaneously, we can simultaneously deliver both heater and trialing. But
To
nowadays,
avoid delivery of high concentrations.
high concentration. But if you are very choosy and if you use half a mac of desflurane and half a mac of sevoflurane, how is it going to cause very high delivery? It is all under your control. What dial setting you want to use, you can use. Does it have anything related to boiling point?
Desflurane has
Yes, sir.
it boils at room
Lower
Boils at a lower temperature. So what will
20
happen if it is allowed to pass through the vaporizer of sevoflurane?
more output than what we actually want will get delivered.
Not only that, the agent with a lower temperature can condense and then mix with the agent in the temperature with a higher temperature. Okay, so that is why in those days, if you see heater, you know what is the boiling point of heater? It is about 35 degrees centigrade. Whereas trialing, the boiling point is 70 degrees centigrade. So if you place trialing here and heater here, what will happen? When the trialing goes into heater, it will condense and mix with the heater. So in order to prevent that, in older machines, they always had the agent with a higher boiling point in the downstream and agent with a lower boiling point in the upstream. Similarly, interlocking is to prevent the condensation of one agent into the other vaporizer and causing output which you cannot measure. That is the problem. So interlocking prevents using two agents simultaneously, which may result in the agent with a higher boiling point condensing and mixing with the one having a lower boiling point. And in the older machines, the vaporizers for the agent with a higher boiling point is placed downstream to prevent the above problem. So trialing had a higher boiling point, so it is always to be attached only after the heater vaporizer, which is called the downstream position. So that is the answer for it. What is the checklist before use of the anesthesia machine you should carry out?
There are 13 steps that should be always checked, sir.
But in the practical exam, you have to say some few important steps that is not going on. What is the first thing you will do before you start using the anesthesia machine?
Check
We have
whether
to look
To
for
check for
the
the
ambu bag,
auxiliary cylinder as well.
alternative auxiliary cylinder and ambu bags.
Okay. Anything else? Machine you are going to use means you are going to give GA, isn't it?
yes, sir.
So other than ambu bag, should you take anything else?
Power supply.
Power supply.
Suction.
Suction. Check availability of working suction, ambu bag and defibrillator. Those are first and foremost. Identify the source of gas supply to the anesthesia machine, whether it is central pipeline supply or a cylinder supply. Then what is the next step? Supposing it is a central pipeline supply, as it is very common in all the major hospitals nowadays. What is the next?
Connection, sir. We have to connect pipe.
Check the touch test to see the connection. But more than that, what important safety precaution you have to do?
To check the pressure.
That will be displayed in the machine itself. You don't have to worry about it. Because pipeline pressures and cylinder pressures are displayed in all the modern workstations. So you will know what is the pipeline pressure. They give you a constant of 45 to 55, isn't it?
Yes, sir.
But if it is a central pipeline supply, what is the most important safety check you should do? If this answer is not given in the examination, it will be viewed very, very seriously. Answer is perform tech test. Then in case of central pipeline supply, make sure a full or half full oxygen cylinder is attached to the machine. This is always mandatory. You do not know when the central supply may fail. So the most important safety feature is you must check whether there is a, at least even if nitrous oxide is not there, air is not there, at least one full or half full oxygen cylinder should always be attached and should be opened and verified before you start the anesthesia in patient. Okay, then you can close the cylinder, but you must open the cylinder. The idea of opening the cylinder is the key to open the stem should be available in the machine. And if you are not going to check at the time of emergency, you cannot be running about for the key to open the stem. So always it's a good practice to make sure that you open the cylinder, oxygen cylinder, make sure whether there is a full or half full cylinder. And then check for oxygen from auxiliary flow meter also. This is another added safety feature that you have to follow. Then what is the next step? After all these safety precautions, what is the next check in the machine you will do?
There's vaporizers.
Open the flow meter and see whether the gas flows correctly in oxygen flow meter, nitrous oxide flow meter, air flow meter. Then open, see whether the dial of all the vaporizers are able to easily open and close. Turn on the mains power supply. That is the next step. Check flow of oxygen, nitrous oxide, air. Check for hypoxic guard. How do you check for hypoxic guard?
We open N2O and see if oxygen is also opening along with it in the flow meter.
Is that the way to check for hypoxic guard?
To raise the nitrous oxide
Huh?
above the oxygen
If
level,
we
like 3:1.
close the oxygen flow meter, then nitrous will also be.
No, if the oxygen flow meter is knob is in close position, by opening nitrous oxide, will you be able to get oxygen flow also?
No, sir.
No, sir.
Will the nitrous oxide first of all flow if you open the nitrous oxide knob without opening the oxygen?
No, sir.
No, sir. No, sir.
So the correct way of checking for the hypoxic guard is first open the oxygen flow meter to save 3 liters and open the nitrous oxide knob also to 3 liters. Okay. So both oxygen and nitrous oxide are now flowing at 3 liters each. Now what you do is close the oxygen knob and bring it to 0. Immediately the nitrous oxide should also drop and come to 0. That is the way to check the hypoxic guard. And once you open the oxygen, then nitrous oxide also along with that flow and come to the same level that you have kept it. Okay. So by just opening the nitrous oxide, you cannot see the oxygen will not flow unless you open the knob of the oxygen. So the correct method of checking for hypoxic guard is you open oxygen, open nitrous oxide to equal flow, close the oxygen and see whether the nitrous oxide bobbin drops to 0 immediately. And once you again reopen the oxygen, nitrous oxide will automatically rise to the previous level that you have kept. That is how the oxygen hypoxic guard is tested. So close oxygen, nitrous oxide should show that is open both oxygen and nitrous oxide. That is the first step. Close oxygen, nitrous flow should stop and resume only when oxygen is opened again. So you then inspect agent, the vaporizers for agent for filling port, agent level, filling port, dial position, open and close the dial settings. Make sure they are easily opened and closed. How is the integrity of the breathing system checked?
By visual inspection and by performing a
Yes. Universal
Functional
test.
analysis of breathing system.
Ethics test and Smith test.
Ethic test is for checking the
Bain.
intelligence of your brain circle, but your regular circle system with the inspiratory, expiratory limb with the Y piece
By doing
connector.
2 back tests, sir.
By doing
2 back test.
2 back test. Okay. How do you do that?
We need to switch on to spontaneous mode, connect the test lung to that of patient end, sir. On squeezing one end of the bag, the other bag should move in opposite direction. Like inspiration, it should expand, and expiration it should come down.
So without normal, you will squeeze the bag, or how do you make it? And what does it follow? What
You
you are
have to
saying?
fill it with oxygen flush
Oxygen flush.
initially, then you have to try
So this is
ventilating it.
we need to check the pressure check machine. Each morning and any time bags or tubes are changed. Close pop-off valve first and foremost, or APL valve, whatever valve is there, close. Occlude the breathing tube by placing thumb or the palm over the EP tube connection port. That is the Y port that is there. To close it with your thumb or with your palm. Pressurize circuit to 30 centimeters of water by using 3 liters of oxygen flow to fill the reservoir bag. Okay. So you open the oxygen flow meter to 3 liters and make sure that the airway pressure gauge shows 30 centimeters of water. Then close the oxygen flow, turn off oxygen flow and watch the pressure gauge for pressure loss. So from 30 centimeters, if it starts dropping, that means there's a leak, or the bag also will start collapsing. It will start developing wrinkles. Then turn on the vaporizer, still with no oxygen flow, and watch for the drop in pressure. So if the drop in pressure happens without turning the vaporizer on, that means the flow meter itself, there is a leak after the flow meter. But the pressure remains 30 centimeters. But once you open the vaporizer, if the pressure starts dropping in the pressure gauge, that means there is a drop in the leak in the vaporizer attachment, especially with the removable interlocking system of vaporizers. This can be a common problem. There may be a leak at the part where you fix the vaporizer, that may have a leak. So you have to individually test for the leak at the flow meter level and at the vaporizer level, and that can be done only by watching the pressure in the airway pressure gauge. So at any point, if pressure loss is detected, increase oxygen flow slowly until the pressure level goes to 30 centimeters of water. And this will now tell you what amount of oxygen flow has happened, that is the amount of rate of leak. For example, if the leak is about 400 ml, 500 ml, and your oxygen flow is kept at 500 ml per minute, and if it is maintaining a pressure of 30 centimeters, that means there is a leak of 500 ml. So flow on the oxygen meter is equal to the rate of leak. This is how the whole thing has to be done. So confirm leakage does not exceed the 300 ml per minute. If leak is more than 300, the leak needs to be rectified, corrected. Open pop-off valve and confirm the release of all the pressure. That is how the pressure check for the breathing circuit has to be done. And next is the checking the scavenging system. Confirm connected to pop-off valve, turn on extractor, and confirm rate of extraction if it is attached to scavenging. And similarly, check ventilator function if it is also fitted. Make sure that it is. For checking the ventilator only, you need a test lung where you can attach it to the endotracheal tube connector end, and you can operate the ventilator to see whether the bag is expanding and collapsing correctly. Okay, so this is how the breathing system integrity is checked. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
What is critical temperature of a gas? Already we have seen that. What is the boiling point of a liquid? These are some of the basic physics questions that will be commonly asked.
The maximum temperature in which a liquid turns to vapor.
Is the boiling point? Is that the definition? Maximum temperature at which it turns vapor. That is not the correct definition. Who else can give the correct definition of boiling point?
Point at which
Saturated.
the transition from liquid to gaseous phase takes place.
Boiling point is the temperature at which the vapor pressure equals the ambient pressure of the atmospheric pressure. So the boiling point of a liquid will vary from place to place. For example, at sea level at Chennai, 760 millimeters is the ambient pressure. If you take the same liquid to Kodaikanal or Ooty at a higher altitude, where the ambient pressure is low, it will boil at a lower temperature. So the definition of boiling point is the temperature at which the vapor pressure of the liquid equals the atmospheric or ambient pressure. Ambient pressure of an open container is the atmospheric pressure. That is the correct definition of boiling point. What is saturated vapor pressure and why is it important in designing a vaporizer?
It is the equilibrium pressure above which the vaporization cannot occur.
Somewhat saturated vapor pressure. Mentioning vapor pressure alone is meaningless because vapor pressure increases with increase in temperature. So saturated vapor pressure is the vapor pressure of the agent mentioned along with its temperature. It is the most important factor of an anesthetic agent that decides the vaporizer design. That means it is at equilibrium with the fluid. Okay.
Variable bypass vaporizers.
Variable bypass vaporizer. Very good.
Injectable.
Of vaporizer.
Direct injectable vaporizing agent.
With the correct terminology?
Injection type of vaporization.
Called measured flow vaporizer. Okay. So this is variable, this is measured flow. What is the difference between variable bypass and measured flow vaporizer?
All the fresh gas flow will go to the bypasser, to the vaporizer, but in measured flow, all the fresh gas flow does not flow through the vaporizer.
In variable bypass, some of them will flow into the vaporizer and some will bypass the vaporizing chamber.
The vaporizer gases and diluent gases are moving separately.
Correct. So variable bypass, the part or entire fresh gas flow enters the vaporizing. This is called the vaporizing chamber. Okay. But to carry the vapor depending on the dial setting. Okay, you can see the example here. Part of the gas is to go without entering the chamber. Part of it comes into that, and finally both meet at the other end and go into the patient. Whereas if you see in the measured flow, this is the blue dot is the fresh gas flow, and there is this fresh gas flow never enters this portion, the vaporizing chamber. And on the contrary, this vapor is allowed to come and join this fresh gas flow as a separate line. Okay. So in the measured flow vaporizer, no fresh gas enters the vaporizer as it is vaporizing chamber. But vapor is injected in measured quantity to the fresh gas passing through a separate tube. That is a major difference. How is the vapor concentration achieved in measured flow vaporizer? For example, in desflurane, you can give up to a maximum of what percentage?
18%.
18% you can give. How is it? You can give 1%, you can give 2%, you can give 12%, you can give 18%. How is it possible when the gases are not directly going into the vaporizing chamber?
By manipulating the fresh gas flows.
Pressure transducer.
There are two things, resistors and pressure transducers. Okay, the variable resistance controlled by the anesthetist adjusting the dial of the vaporizer. That is one part. So when you operate the dial, you are causing a resistance, variable resistance to the flow of the gases, and the differential pressure transducers situated both after the vaporizing chamber and in between the fresh gas line and the vapor line. These three things only decide the concentration that is delivered. That is the variable resistance controlled by the anesthetist by adjusting the dial, and there is a differential pressure transducer present immediately after the gases are coming out from the heated vaporizing chamber, and there is a communication between the fresh gas flow and the vaporizing line, which where there is a differential transducer. These three things only determine the final output of that. Okay. So that is all for today. We will stop here. We have more fun. Okay.
Yes, sir.
So what is your feedback or opinion about this type of question and answers type instead of blindly talking about the whole thing? Do you find it interesting or boring?
Interesting.
Okay. So we will continue with this sort of question answers. So we have covered now almost starting point of the anesthesia machine, like gas delivery to the hanger yoke assembly. Of course, I have not talked about the pressure regulator, how it works. We have talked about the pressure gauge, the Bourdon gauge system. Then we have talked about the delivery of gases to the flow meter assembly. Then flow meter assembly, we have seen a few points on the vaporizers, and we have come to the common gas outlet and breathing circuit system. So almost the entire tracing of the gas delivery system has been completed today. Okay. So we will see some more physics involved in the vaporizers, which are commonly asked in the exam. And then we will go on to the other equipments that are used in management of anesthesia, like your laryngoscopes, your endotracheal tubes, the questions that are asked on that, the suction apparatus, the suction catheters, other regional anesthetic technique equipments like spinal needle, block needles. Okay, like that we will see in the next class. Okay.
Yes.
Thank you.
Sir, can I just